All right. So here's a quick review of what we did last time. And this is what we're gonna, some of these concepts we're gonna be using in the later part of this lecture as well. So we started out with our definition of what a unit step is. So that's pretty easy to understand. It's just a step function that turns on at time t equals 0 and then just stays on with an amplitude equal to 1, right? And then we talked about something called the unit impulse, right? So let me something called the unit impulse. Okay. And the unit impulse is a function that just resides at time t equals 0. Um, and it has some specific properties. And that specific properties are that it is of infinitesimally small duration and it is of infinitely high amplitude, such that the area under this signal is always going to be equal to 1. So this is some hypothetical signal or a mathematical signal that we define, a construct that we define, which is going to be useful in some of our later analysis as well. Okay, so that's a unit step, and the notation that we use is delta of t, and the depiction is it's an arrow residing at time t equals 0. And the height of that arrow depicts what the area under the curve for this signal is going to be. So that's a unit step, right? And then you can talk about shifting. So delta of t minus t naught, as you can see, or delta of t plus t naught, and so on and so forth, right? So the same sort of shifting operations can be applied to unit step as well as to unit impulses, all right? Then we talked about what the relationship between the unit step and the unit impulse is. And it turns out, as we analyzed, the unit impulse is just a derivative of the unit step, derivative with respect to time. Okay. And then conversely, if you were to define the unit step as a function of unit impulse, that's just an integral of from minus infinity to t, right? So u of t, so u of t is just simply the integral of the delta from minus infinity all the way up to t. So and as we saw, okay, this turns out to be equal to 1 only when t is greater than 0, and otherwise it's 0, which is just the definition of unit step, right? Um, and then finally, we did some of these properties of the unit impulse, right? So especially these properties B and C are most relevant. And these are called the sampling properties of the unit impulse, right? So this B's property that you see, what if I multiply a signal x of t with the unit impulse? What happens? What happens is that unit impulse, all it does is it samples a signal at the time at which the unit impulse resides. Okay, so that's what a unit impulse does. In other words, if I were to depict this graphically in just here, so if there's a signal which for example looks, which is an arbitrary signal, so as a function of time, so let's say this is t, right? And if I multiply this with a unit impulse, so that's a unit impulse which resides at time t equals 0, right? And this green signal is x of t. What happens if I multiply these two together? What I get is a signal which is just going to be equal to an impulse which once again resides at time t equals 0, except that the area under that impulse or the height of that impulse is going to be equal to x of 0. In other words, what we've done is x of t ki jo value which existed at time t equals 0, that's actually what we've sampled, and in the form of an impulse. So that's a sampling property of the unit impulse. Jizan, please go ahead.
So what do you mean by x at zero? Like x at zero पे जो भी कोई value होगी वो
Yeah.
एक finite real value होगी, and the impulse at x at zero is infinity. So infinity into some finite value should be infinity. So what
Yes.
do you mean by x at zero जब आपने वो orange लिखा?
So as I just said just a few seconds ago, that the height of the arrow indicates what? That the height of the arrow does not indicate that is the actual amplitude, but rather the height of the arrow indicates what? The area under the curve, right? So when I depict x of 0
Okay,
here, that means
I
the
got
height
it.
is infinity. That's granted. But the area under this impulse is going to be x of 0. Okay, is that clear?
Yes, sir.
Right? So that's a notation that we're going to keep on using. This is not the actual amplitude. It's the area that we're going to be depicting with x of 0, right? So that's what the multiplication with the unit impulse does, right? And then property number C was simply that if you then, after this multiplication, you just integrate it out, right? You find the area under the curve. So you're simply going to get x of 0, right? So in other words, this impulse that I have, um, right? So this impulse that I have, this signal that I have, if I integrate this from minus infinity to plus infinity, what am I going to get? I am going to get the area under this curve, and the area under the curve is just simply equal to x of 0, right? And that's exactly what is depicted in this equation here. I mean, that's what we found out from last time, right? And then you can come up with extensions, and there were some extensions that we talked about. What if the impulse now resides at t naught, right? Not at time t equals 0, but rather at t naught. And if you really grab the concept, right? So if you understand the concept, it should be very, very clear that all is going to do is going to sample the signal at t naught, and when you integrate out, what you're going to get is a real number x of t naught, which is a constant, which is not a function of time, right? So it's only a function. It's not a function of t. It's a function of t naught. Okay. And then I had these exercises here. I'm hoping, hopefully, all of you would have done these on your own. Okay. Um, all right. So I don't want to say anything about these exercises at the moment. So I can take questions about these perhaps in the office hours. All right. Okay. Now, then what we started our discussions on is our systems, right? So a system is nothing but a box which has a certain input, which we're going to denote by x of t, and a certain output, which we're going to denote by y of t. And the system does something to the input and outputs it as y of t. Okay, and then we say, KG, there are certain properties which characterize systems. So systems, for example, the property number A, as you see, could be with memory or without memory, right? So if it's a system is memoryless, all that means is that the output at any time t does not depend on the input. It only depends on the input at that time t, neither on the future nor on the past. Okay, so for example, example number one here is a memoryless system because it's just the output at time t is only dependent on the input at time t, and this is a system with memory because it depends on the input for all times in the past, starting from minus infinity all the way up to the current time. Okay. Zan, do you still have a question, or was from this before? All right, thank you. All right, so then we talked about causality. Causality is a system is causal if the output at any time t is only dependent on the present, either on the present or the past, but it cannot be on the future. So if it does not depend on the future, we say the system is causal. But if there's dependency on the future, then the system is non-causal, right? So, and then we did some examples. Okay, so what we're going to do today is continue this discussion on some other properties. And the third property that I have for you is that of stability, right? So stability, I mean, what is stability? I mean, if there's any ideas that you may have, I mean, how would you say, Kitty, if I told you that a certain system was stable, what would that mean? What comes to mind? क्या ख्याल है? I mean, any guesses? जी हमजा.
सर अगर हम अगर हम विद रिस्पेक्ट टू टाइम बात करें स्टेबिलिटी की, so system does not disintegrate with respect to time, it's not affected by its own factors.
Okay, what
मतलब
do you
जो
mean by
input है
disintegrate?
सर, अगर मैं यहाँ पे एक रेडियो एक्टिव सिस्टम की बात करता हूँ या फिर अगर मैं किसी रेडियो एक्टिव प्लांट की बात करता हूँ, इट कम्स विद द लाइफ. मतलब
Yeah.
रेडियो एक्टिव जो आपका पावर प्लांट होता है, आपको पता होता है कि इतने अरसे के बाद आपको ये पूरा एरिया इवैक्यूएट करना पड़ेगा. सो दैट सिस्टम इज नॉट रियली स्टेबल इन दैट सेंस,
Okay.
इफ आई माइट.
All right. So, all right. So I would rather give you a simpler example. So, what the system that you refer to, yes, that can be unstable. But I'd say if I put this pen on the table, right, and it somehow balance this out, right, and would you categorize this as a stable system or an unstable system if this is balanced out? And I would argue that this is an unstable system because only a small input would result in a very, very large output, in the sense that it's so unstable that abhi to balance hua hai, but if I just give it a small shove, it's going to result in a very, very large displacement. right? And it's just going to fall, right? So that's an unstable system, and that's what we know from high school, from some of the introductory courses that you may have had already. So and now what we want to do is we want to come up with a mathematical definition of what stability entails, right? And very broadly, roughly speaking, a system is stable in which small inputs lead to small outputs, or another, or rather, I would rephrase that: small inputs results in outputs that do not diverge, right? So small inputs cannot result in infinitely large outputs. If that happens, then we say that the system is stable, right? So that's just a rough definition, or an intuitive definition. More formally, and that's what I would write here, a system is stable if a bounded input results in a bounded output. Okay. Now, I mean, you would immediately ask, what do I mean by something being bounded? Or remember, the input is a signal, the output is a signal. When I say that a signal is bounded, what does that mean? Ji Mahanur, kya khayal hai? So what is meant by bounded? A bounded signal?
Within certain limits.
Within certain limits. Excellent. What is to be within certain limits? I mean, this is, the time has to be within certain limits, or
Input.
You're right, Banur. Excellent. I mean, I just want to get some more things out of you, right? So, what do you mean by uh, within certain limits? Can you थोड़ा सा और precise कर सकती हैं इसे?
Sir, जैसे आपने let me think. Sir, I don't know. I'm not
Okay,
sure.
that's fine. That's fine. Ibrahim, you want to say something?
So I think it is finite and not infinite. Like, it's within some, right?
Within something, what? Okay, your voice is थोड़ी कट गई. So, Hassan, you want to say a finite signal amplitude? Right. So that's that's actually right. When I say input is bounded, what that means is its amplitude always stays within certain bounds. And if I were to write this mathematically, I would say an input is bounded if an input x of t is bounded if the absolute value of x of t stays less than some bound b, which is less than infinity, right? For all t, for all time t, from minus infinity to plus infinity. And what that means is, if I were to sketch this out, right? So what that means is, if this is the zero axis, this is the zero axis, then b is some finite number, right? And that finite number, for example, could be this plus b, and this is minus b, right? And what this statement means here is, that the signal is always going to be within these two lines, can never go up, can never go above the threshold plus b, and can never go below the threshold minus b. And that's what is meant by the input being bounded. Okay, जी Zain.
सर ये हम लोग जो जो सिस्टम की आउटपुट की बात कर रहे हैं, तो जो उसकी इनपुट की बात कर रहे हैं, वो पूरे रियल लाइन पे होगा या फिर उसकी इनपुट भी लाइक समवॉट बाउंड होगी?
So पूरे
अगर
real number.
कहाँ का होगा सर, तो फिर लाइक इफ वी एक्चुअली, फिर तो हर सिस्टम ही बाउंडेड होगा. अगर हम लोग उसकी इनपुट की जो डोमेन है उसको रिस्ट्रिक्ट कर देंगे, तो उसकी आउटपुट की डोमेन भी रिस्ट्रिक्ट हो
No,
जाएगी.
that's not true. That's not true. I can give you counter examples. I'll give you counter examples, right? So the first point you want to make, I would once again pick up on that, which was, okay, what does this mean? Okay, it has to be bounded for all time. Yes, it has to be bounded for all time instances, and I would explicitly add, therefore, for all time t on the number line, on the real number line. For this condition has to be satisfied for all time t on the number line. If this condition is satisfied for all time t on the number line, then I'd say that the input is bounded. Okay. If the input is bounded and the output therefore is also bounded for all bounded inputs, that's when I'd say that the system is a stable system. Okay, so that's a definition, and this is called a certain type of stability, and this is called bounded input, bounded output stability, which is BIBO stability. Okay, and of course, so let me, and bounded output means what?
मैं से बात ना करो। इसके आगे black bag के अंदर रखा था। उनके अंदर।
So, Manur, can you mute yourself, please? Right. So this is.
I'm so sorry, sir.
That's fine. That's fine. Y of t also has to be within from minus infinity to plus infinity. So it has to be within certain some other bound, okay, for all time t, for all time t. Right. So let me say this is by and this is bx. Okay. So let me take some questions. So Zan, did you have a question about this or from somewhere else? Pelika. All right. Ji Hassan, go ahead.
सर जो हमने previously सीखा था वो energy signals and power signals,
Yeah.
उसमें हमारा जो input था that was also some x of t.
Yep.
Right, some input signal and that gave us an output signal.
Yeah.
उसमें भी क्या कहते हैं, like if for example we got an infinite energy signal, उस case
Yep.
में we don't have a bounded output, but then we did get a finite power signal.
Okay.
So how do you?
So I want to make a point of clarification here. A bounded input or bounded signal is not necessarily an energy signal. The energy may still be infinite.
Okay.
Right? And the simplest example for that is a unit step, for instance. Right? Unit step is a bounded input, right? Because the amplitude always stays within a certain bound, which is less than 1. Okay, less than equal to 1. But the energy is infinite because when you integrate it over all time, that's when you get infinity. So the energy is different, and the input being bounded is different.
Okay, and the energy does not count as the output, like जो हम यहाँ पे bounded output जिसको define कर रहे हैं.
So a signal being bounded or unbounded is a property which is different than a signal being of finite energy or of infinite energy, right? So these are two different.
Okay, thank you.
Okay. Now, coming back to examples, right? So what kind of examples can we have? And I'll give you 2. Or I can give you more to give you. There was a counter examples to what Zan said as well. So Zan said, Kiji, if the input is bounded, right? I think his intuition can't try to predict what kind of a system would result in a bounded output, an unbounded output. Is that right, Zan? I mean, that's what you said, right? कि bounded input से
Yes, sir.
unbounded output कैसे आ सकती है? Right?
Yes, sir. Yes,
right. So here's an example. Here's a system. Let's say the system description between the input-output relationship is the following: that y of t, which is the output, is equal to minus infinity all the way up to t x of tau d tau. Right. So this is a system. This is actually an accumulator system. All this does is कि जो भी input आ रही है ना, उसको minus infinity से minus infinity से all the way up to t, it integrates or finds the area under the curve. Okay. So is this system a stable system or an unstable system? And I claim that this is an unstable system. In order to show that this is an unstable system, all you need to do is to find one counter example, a counter example where you pick a bounded input and show that this will result in an unbounded output. Okay, so given that this is a relationship, given that this is the input-output relationship, so remember this is क्या relationship है? Okay, there's there's the input x of t, right? And then what it does is it minus infinity से t तक इसको integrate कर देता है, right? And that's what you get at y of t, right? So can somebody try to give me an example of an input or or one input which is bounded, yet it results in an output which is unbounded? Okay, right? Somebody else? Munim? Right, so Hassan said it's a constant function, and that's exactly right, right? I would maybe come up with a different example. Okay, let x of t equals u of t, right? So it's a unit step. Is unit step a bounded signal or an unbounded signal? And it indeed is a bounded signal. So this is a bounded input, right? What would y of t be? So y of t is going to be integral from minus infinity to t of u of tau d tau. So what does this integral evaluate to? Can somebody help me here? So what is this integral equal to? So how should I evaluate this integral? Right, so this is, I know u of tau is equal to 1 only when tau is greater than 0. For all values of tau which is less than 0, this should be 0, right? So if I were to try to visualize what's going on, right? So with every equation that you see, I mean, every integral that you see, I mean, the first thing you should do is you should try to visualize the equation. What does this equation really represent, right? And what this equation represents is that there is a signal in which the independent variable is tau, right? And that function that you're integrating is a unit step, which is equal to 1 for all values of tau greater than tau equals 0, and is equal to 0 for all values of tau, which is tau is less than 0. And then if I start integrating this, right, I have to integrate it from where to where? From minus infinity to t, right? And if t is less than 0, what happens, right? So let's say this is where t was. This is where t was, and I was integrating from minus infinity all the way up to t. What would I get as this area?
0.
0, right? So I'm going to get 0, right? So this is, I know that this integral is going to be 0 for all values of t, in fact, which are less than 0. Is that correct? Because if this t, I push up just a little bit, but before 0, the area is still going to stay 0. Okay. But what happens when t is positive? Right? What happens when t is positive? So let's say this is where t was. Okay. So then what is this area equal to? Right? So for all values of t, so which are greater than 0, this would be integral from where to where? This would be from 0 all the way up to t of what? 1 d tau. And this is equal to t. Okay. We don't get a constant area. We get an area which starts increasing as I start increasing t. Okay. So, I mean, you see, this is a rectangle. So the rectangle area jo hai, kya banta hai? Right? So this is a rectangle, right? So what is the area on the curve? The area under is t, right? So if I conclude what this integral corresponds to, or the output is going to correspond to, so that conclusion is that y of t is going to be equal to, and this is a piecewise description, is going to be equal to 0 for t is less than 0, and is going to be equal to t for t is greater than 0. And I can put this very, very nicely, and I can say this is just simply t times u of t, right? Using the unit step definition that we have already. Okay. Now, is this a bounded output or an unbounded output? G Saad, what do you think? Is this a bounded output or an unbounded output? Does this always stay within a certain bound? Or does it diverge?
Sir, it depends. Sir, it depends on the value of t.
It depends on the value of t. But does it always stay, no matter what time t is, does it always stay within a certain bound? Does it always stay finite? Or does it diverge?
No, sir. No, sir. No, sir.
Right? It diverges, right?
Yes.
Right. So if I were to sketch this out, if I were to sketch the signal out, this is what the signal looks like. If this is time t, so the signal I get is equal to 0 for all time t is less than 0, and then it starts increasing linearly and keeps on increasing. So it diverges, and therefore this is unbounded. Okay. So what we've been able to show is that for this system, we have shown the existence of bounded input that results in an unbounded output. And because of this fact that we've actually proved or shown, we can conclude that this system is an unstable system. Right? So mind you, so all it takes is just one bounded input resulting in an unbounded output, and that's enough to show that the system is unstable, right? Because there will exist many other bounded inputs which may result in a bounded output still, right? And you can try to think of, can you think of some bounded input which will result in a still a bounded output? Can somebody think of that? क्योंकि कोई ऐसी बाउंडेड इनपुट हो सकती है जिससे इसी सिस्टम से बाउंडेड आउटपुट निकल रही हो. Excellent, Umar. Zabardast, right? So the sinusoid, right? You find the area under the curve for sinusoid, it will always stay bounded, right? But that's not enough to show that the system is stable. That's not enough to show that the system is stable. Okay? So, all I need is just one counterexample, which we have actually seen. And therefore, for this particular example, the system is unstable. So Hamza Rafi says x squared, y equals x squared. So y of t equals x squared of t. And that's true. But so that still is a stable system. Although I think what you meant was something different, Hamza. आप जो है x squared का area under the curve निकाल रहे हैं, you're forgetting about the time axis, right? So there's a time axis there as well. Okay. All right. Anyway, so let me give you another example, right? So and of course, I mean, if the first example was for bounded and an unstable system, the second example is going to be for a stable system, and the input-output description is the following. So y of t. The output is defined as just the e exponential raised to x of t. So there's some system, hypothetical system, arbitrary system out there, and all it does is it takes the input and computes the e raised to power that input and has it out as the output. Okay. By the way, is this a memoryless system or a system with memory? Just a side point here, tangent here. Does this system have memory or not?
Yes, sir, it does. I mean,
it does have memory.
so.
Ji, Masna?
Sir, I don't think it has memory because it's depending on the present क्योंकि t के साथ कोई plus या minus आगे नहीं लगा हुआ.
Excellent, right? So it does not have memory because the output at any time t is only dependent on the input at that time t, neither on the past nor on the future. Okay, so this system does not have memory, right? It's a memoryless system. Okay, is this a causal system? Is this a causal system? And it turns out it's a causal system as well because it's only depends on the present, not on the future. Okay, so it's a causal system as well. But what we're interested in finding is it a stable system? And I can tell you for a fact that this is a stable system. how would you go about arguing that this is a stable system? Maz, how would you go about arguing that this is a stable system? You know, I am very, very inclined towards instituting class participation. 5% of the course would be CP. Okay, so that I am not talking to blank screens. I mean, I'm talking to actual students. Okay, anybody? How would you argue? Ji Hamza.
Sir, मुझे like actually समझ नहीं आ रहा कि how like will this be a bounded system, क्योंकि sir if we assume that x is a constant, sir t की तो value अगर आप linearly grow करें, so shouldn't this be a monotonically growing function?
But x
So
of t,
how is
no, it's not a monotonic. See, I mean, so once again, you try to visualize what's going on. What you're saying is, at any time, so what this system is saying is, at any time t, jo bhi x ki value hai, the output is e raised to power that value. And if that x ki value is bounded, what do you expect e raised to power that value to be? Would you expect that to be unbounded?
oh sir yes नहीं समझ आ गया मुझे
Never.
सर मैं क्या गलती कर रहा था.
Never. So
ठीक है
this is
सर.
exponential e raised to power, because it is the e raised to power function is a very specific type of function, and it's called a. So if the power is bounded, e raised to power that power would always be bounded. Okay, and that's a fact.
Yeah.
Okay,
ठीक है sir, thank you.
So what we conclude is if x of t absolute value is less than b, what that means is that x of t is less than b and x of t is greater than minus b, right? It's always going to be within minus b and plus b, right? And from here, we can conclude that, or from here, this implies that e raised to power, or rather, y of t, which is e raised to power x of t, this is always going to be less than e raised to power b, right? Because exponential is a monotone function, is a monotonically increasing function. Okay, so so अगर मैं कहूँ कि जी आप जो x of t है, if x of t is less than 2,
okay,
I can claim that e raised to power x of t would always be less than e raised to power 2.
Yeah, you can.
Does that make sense?
Yes, sir. Yes, sir.
That because e is as you increase the power, the e raised to power also increases. So there's a monotonic relationship. Okay.
Yeah.
On the other hand, if x of t is greater than minus b, चलिए जैन आप ही बताएं मुझे. So if x of t is greater than minus b, what can you say about y of t? Can you say that this is greater than something?
So we can say that it's greater than like so 0 से बड़ा होगा sir.
0 से नहीं बड़ा होगा, e raised to power minus b से बड़ा होगा. 0
Yes,
से बड़ा होना ही होना है.
जी सही है, डिनोमिनेटर छोटा होगा या
0 से क्योंकि e raised to power something is always positive. Right? E raised to power a real number is always positive. Okay, so this must always be greater than 0.
Yes, sir.
Right? And by the way, okay, so that's a good point that you make. Okay, so it's always going to be greater than 0 and it's going to be less than e raised to power b. That's another way to show, okay, this is always going to be between finite bounds. So it's never going to diverge. So the point we're making here is that this will never diverge, right? If
यहाँ पर जरूरी है कि जो हमारी पॉजिटिव बाउंड है और नेगेटिव बाउंड है वो सेम हो.
No, it's not necessary. It's not
So
necessary.
all we need to do is find some values x के लिए जिसके लिए वो बाउंड है और बाउंडेड है जिसके लिए y के लिए बाउंडेड है to prove.
Say again, please.
So all we need to do to prove is that we need to find a value of x, the two values of x जिसके लिए वो bounded हो और जिसके लिए उसकी output भी bounded हो. अगर
Yes.
हमें prove करें.
Yes, correct. जी हसन.
सर इसमें आपने पहले से स्टेट कर दिया था कि हमारा जो x of t वो बाउंडेड है.
Yes, because in order to prove stability, what you're dealing with are bounded inputs only. right? And so that's why I say, Kiji, let me assume that the input is bounded. And if the
Right.
input is bounded, what I've proved is the output is always going to stay bounded.
Right.
Right? So
Okay.
I'm only concerned about bounded inputs to prove stability. Okay?
Okay. Thank
Ji,
you.
Hamza?
जी sir, to prove that it is a if this signal is a bounded, तो सर हमें उसके लिए दो ही इनपुट्स लाइक दो डिफरेंट वैल्यूज चाहिए होती हैं या फिर एक ही वैल्यू चाहिए होती है, सो यू कैन प्रूव दैट. लेट मी सर रीफ्रेज माय पॉइंट के
Yeah.
यहाँ पे आपने दिया हुआ है ई पावर बी और ई पावर माइनस बी.
Yeah.
सर अगर हमने इसको बाउंडेड प्रूव करना है, सो वी कैन जस्ट शो के इट इज लेस देन ई पावर बी, तब लाइक आप उसकी अपर बाउंड दे दें उसका कि ये इससे हमेशा
Okay.
नीचे रहेगा, सो इट विल ऑलवेज बी बाउंडेड.
Yeah, but you want to say कि नहीं, नीचे से भी bounded है, right? So it's bounded from above and it's bounded from below.
अच्छा
Because
नीचे से भी करना है, ठीक हो गया.
yeah, because if the amplitude goes to minus infinity, and I would classify that as an unbounded signal. Okay,
All
because
right,
it
so
diverges. It diverges.
it's important to have the both. ठीक हो
Yes,
गया सर.
lower and the upper. Okay. All right. Right. Hamza, you still have a question? If you don't, if it's clarified, if you can lower your hand, please. Right. Thank you. Achari. So the next property we want to do are actually the next two properties we're going to do. And which property is that? Let me see. So it's D. So the next two properties we're going to be doing are extremely important because the next chapter is all about these two properties, right? And the first of these two is something called time invariance, right? So there are systems that are time variant and there are systems that are time invariant. Okay, so when I say that that a system is time invariant, I mean, what comes to your mind? I mean, any ideas, any guesses? And because of this, it's there in the meaning itself and in the definition itself. When I say the system is time invariant, what does that mean? All right, Jisad?
Say that the system does not depend on time, like the output it does not depend on time.
Right. So remember, it does not depend on time itself because all our independent variable is time. So it's sort of not correct to say that the system does not depend on time. But rather, a more precise definition would be that the properties of the system would not change with time. And that's when the system would be time invariant. Okay. So in other words, so let's say there's a circuit that you're working with, right? So there's some resistance and there's some capacitance or there's some inductances in there. Okay. If the resistance and the capacitance and the inductance does not change with time, you would expect that the behavior of the system today is going to stay exactly the same as the behavior of the system tomorrow. Right? Because the R, C's, and L values do not change with time. So therefore, the system behavior would not change with time as well. And I would classify this system as a time invariant system. But on the other hand, for the same system, let's say that the resistance is dependent on temperature, which it is, right? And if the temperature changes from the morning to the daytime, right? As the resistance changes, because of the temperature, you would expect the behavior of the system to change as well, right? And the behavior of the system, therefore, in the morning is not going to be the same, exactly the same as the behavior of the system in the daytime. And therefore, I would classify this system as a time variant system because the properties change with time. Okay, just like that, you buy a new car, okay, and the system is the input is the amount of fuel going in, and the output is the acceleration profile, let's say, right, is a function of time, and you would expect this to degrade as the car ages, right? And therefore, this on that longer time scale is not a time invariant system, but rather a time variant system. Okay. Now, how do we define this formally? So this was all this monologue or this prelogue was an intuitive definition of what this means, right? Or time invariance means. Okay. There's a mathematical definition here now, right? So you go back to the RNC circuit, right? So I would say, KG, if I provide an input x of t to the system today, I get an output y of t, right? And if I provide the same input tomorrow, I would expect the same output tomorrow as well. Does that make sense? Right? In other words, a system, so this is what, so first off, I'll use this notation here to represent something. So x of t and y of t. And what this notation means is that there's a system here in which the input is x of t and that resulted in an output y of t. Okay, so this is the notation we're going to be using. Is that clear? Is this notation clear? That x of t, right arrow, y of t, that means there was a system, some box, in which the input was x of t and out comes y of t. So this is a notation I'm going to use. I say the system is time invariant, is said to be time invariant if a shift or time shift in input results in the same time shifting of the output. In other words, if x of t results in an output y of t, I would expect that the input x of t minus t naught to result, if there's the same system, to result in an output which is y of t minus t naught. Right? So if I delay the input by t naught, I would expect the output to be delayed by exactly the same amount t naught. And that's a definition of time invariance. And it's a mathematical definition of time invariance, which is, consistent with what the intuition that I built up, right? Ji Hamza.
जी सर, मैंने पूछा था कि is there a sort of overlap between periodic functions and time invariance?
No.
All right.
No, because now we're talking about see, a periodicity was a property of signals. Now we're talking about systems, right? And we're talking about properties of systems now, not of signals anymore. Yeah.
ठीक हो गया सर.
Ji Hassan, go ahead.
Sir, if a system is supposed to change after a time shift, suppose it does,
yeah,
doesn't that automatically mean that there is some other independent variable that it depends on? So it's not just time. Like there could be some other, like for example, temperature. So
okay, so the temperature itself, because that's something innate, or some resistance, for example, that's something innate of the inside the system, and that depends on some external factors. That I agree with you. Okay, which is a function of time.
Yes.
Right? It's just that, Kiji, the beauty of all of these mathematical abstraction is that we will not, this definition would not restrict ourselves to or limit ourselves to anything of that sort. This is a mathematical definition that covers everything. It's generic. अब उसके पीछे क्या underlying physical phenomena है, right? That has no bearing on this mathematical theory.
Right.
Underlying physical phenomena बहुत सारे हो सकते हैं. It's just that we're not going to be concerned too much about them.
But even if you're not thinking about the physical phenomena, if we see some change that is not dependent on time, doesn't that automatically mean that there is some other independent, whatever that is, there would be some other independent variable that we have not accounted for?
Hassan, not necessarily, because that other, for example, temperature, right?
Yes.
That temperature changes with time.
Yes.
So the independent variable is time.
Still time.
Which affects temperature, which in turn affects resistance, which in turn affects the system behavior. So it's actually the independent variable is still time here. Okay. Right. Any other questions? Right. So once again, a system is time invariant if a shift of T naught in the input results in exactly the same shift T naught in the output. Right. That's the definition of time invariant systems. Okay, and let me give you some examples, two examples in particular. Right. So example number one. So I have an input-output relationship given by the following: y of t is equal to sine of the input. Okay. By the way, is this system stable? Mustafa, do you think the system is stable? Mustafa Siddiqui. Mustafa Siddiqui, are you there? Right. So I do really need to 5% CP. Okay. So G Masna, why do you think it's stable?
Sir, because it's sine, so bounded है उसका
Yeah. Excellent.
output.
Right. So because if x of t is bounded, I know that sine of anything always stays between -1 and +1.
Yes, sir.
Okay. So it's a stable system because the output is always going to stay bounded no matter what the input is. Right. But this was a sort of a tangent. But we're now interested in finding whether this is a time invariant system. In order to check whether this is a time invariant system, all I need to do is to see kg whether a time shift in the input results in a time shift in the output, the same time shift in the output or not. Okay. So if I know that x of t results in an output which is y of t defined as sine of the input. Let me see what happens if I change the input to x of t minus t naught. What would be output? So let's say this is y x1, y x1, and this is y2. What would be the output? So the output is just simply, Zizan, go ahead.
सर जो आउटपुट होगी वो सिंपली लाइक t माइनस टी नॉट पे वैल्यू होगी. ऐसा कब होगा जहाँ पर ऐसा ना हो रहा हो? लाइक ऑब्वियसली बात है, जब मैं x ऑफ t y ऑफ t है तो x ऑफ t माइनस टी नॉट y ऑफ t माइनस टी नॉट ही होगा. सो लाइक
Are you talking about this system or you're talking about in general?
नहीं, आई एम टॉकिंग अबाउट दिस कॉन्सेप्ट इन जनरल, लाइक
This system
time
or
shift.
any system. I mean, are you saying that there can exist no system in which something like that could happen?
Yes, I want you to actually show me system जहाँ पर ऐसा ना हो रहा हो.
Okay. So इसलिए I will of course show you that. I mean, just like what you said कि stable कभी नहीं हो सकता, unstable तो कभी नहीं हो सकता system, right? Just like that, I will show you counter example. But let's talk about this example first, right? And it's clear कि y2 of t is just simply sine of whatever the input was, and the input here was x2 of t, which was the shifted sine of x of t minus t naught, right? So this is x1 and this is x1, right? And then I see kg because I shifted the input by t naught. I want to see whether the output that I get is that the earlier output shifted by t naught as well or not. And indeed, if I can just compare y1 and y2, I can compare y1 and y2 and clearly see kg y2 of t is indeed y1 t minus t naught. If I shift y1 by t naught, I will get the output y2. And therefore, this means that the system is indeed time invariant. Okay. Here's an example for you, Zen. And that is y of t equals t times x of t. So what this system does is it just takes the input and multiplies that by t. So by the way, is this system a memoryless system? Jisad, is this a memoryless system?
So I don't think so. Yeah, I think so. It is a memory system because the input, the output depends on just t.
Excellent. Or I think you said no, sir, on that CP thing, right? Is that true?
Yes, yes, yes.
So don't worry. Up tak my book, in my books, you're acing the CP, right? Because the CP does not mean that you provide the right answers, right? CP
Okay,
means
sir.
you participate and not stay quiet when and not attend the classes, live classes. Okay.
Okay, sir.
Anyway, so y of t equals t times x of t. So that's, as you said, as rightly said, this is a memoryless system. Is this a stable system, Saad? Achha, nahi, let me.
Yes.
Okay. Yes.
No, sir.
Right. G. Ahmed, do you think it's a stable system?
Y of t is equal to tx of t.
Yeah. So is this a stable system or not?
Depends on what x of t is, but I think no, because it depends on the value of t. It will have large jumps.
Good. Excellent. So if x of t is constant, if x of t is bounded, and then multiplied by t, as t increases, it's going to start diverging, right? It's going to start diverging, right? So as t goes on increasing, the output goes on the amplitude of the output goes on increasing as well. Okay, so therefore this system is not a stable system either. Okay, but what we're interested in, at the moment is whether the system is time invariant or time variant. Okay, so here's what we'll do. We'll say, KG, my input being x1 of t results in an output which is y1 of t, which is simply equals t times x1 of t. Okay, so all you do is take the input multiplied by t. That's what the system does. Take the input multiplies by t. Okay, now let's say there's another input x2 of t, and that input was just simply the first input shifted by t naught seconds. What would this output be? This output would be y2 of t equals to then t times the input, which is x2 of t, right?
Yes, sir.
But x2 of t is t times, so x2 of t is x1 of t minus t naught, right? And then what you do is you compare y1 and y2, and you try to verify whether or not y2 is a shifted version of y1. Is y2 a shifted version of y1? Then?
So I don't get the idea of like how can we actually check a shifted version hai ki nahi hai?
So you just compute y1 of t minus t naught. What is that equal to? That's just t minus t naught divided by x1 of t minus t naught. Right? If want to shift y1, instead of just t, I just replace t with t minus t naught.
Yes, sir. Yes.
Okay? And this is the shifted y1 is just t minus t naught multiplied by x1 of t minus t naught. Is this equal to y2 of t?
No, sir.
It's not equal to y2 of t. So therefore the shift is not equal to the shift of y1 is not equal to the output that I get when I shift the input. So what I conclude is that a shift in the input by t naught seconds does not result in a shift in the output by t naught seconds either, always. Okay? And therefore this system is a time variant system. So therefore system is time variant. Okay. All right. Any questions about time invariance before I move ahead?
सर मुझे y2 नहीं समझ आया कि हमने उसमें क्या कहते हैं t को हमने क्यों नहीं चेंज किया t minus t naught में?
Because what the system does is, because the system, all it does is it takes the input and multiplies that input by t. That's the system definition. Okay? And what is the input? The input was x1 of t minus t naught. The output kya hogi? Output would be t multiplied by the input.
Yes.
Right? Now what input kya thi? Which was x1 of t minus t naught.
बट आपने यहाँ पर x2 के अंदर आपने t को रिप्लेस कर दिया t1 minus t0 से.
Yeah.
So if t is equal to t1 minus t0, तो बाहर वाले t को आपने क्यों नहीं चेंज किया?
T is not equal to t1 minus t0. T is not equal to t minus t0.
Oh, अच्छा वो x1 है.
Yeah, so the
Oh.
input, right? So the input changes.
फिर असल में तो जो t x2 of t है वो एक टाइम डिले हुआ है t0 का x1
Yeah.
का. Yeah.
Yes, excellent, right? So x2 is just the time shifted version of x1, right? D Masna, you have a question?
Sir, can we safely say that if there is a t outside the input, then it's the system is time variant?
No, not necessarily.
Okay.
Okay, so this is one example of such systems, but there would be many others.
Okay.
Okay. And perhaps in the homework problems or at the end of the chapter problems and other examples in the textbook as well, in your readings, you'll find many examples of systems which are time variant, yet they do not have a t outside.
Okay.
Okay. All right. So the next property is that of linearity. And once again, this is one of those two properties which are going to be extremely important as far as our discussion, subsequent discussions and subsequent lectures are going to be concerned. Okay. So when is a system linear? And this is something that maybe perhaps in some form or the other you may be familiar with. I mean, when are things linear? I mean, what does linearity mean? Anyone? Physics? Yeah, Musa.
So do you mean a linear differential equation or like?
Yeah. So if there's a linear differential equation, okay. If there's a linear differential equation, why is, I mean, what property does it? The properties make it linear.
I think if the dependent variable does not have a power greater than 1.
Okay.
In that case.
Yeah, but
or it doesn't appear in sign or cause. Or...
Right. So that's not why it's called linear. The linear की असल definition है this. I mean, that results in the fact that the powers cannot be greater than 1.
Right.
But the actual
it's basically I think शायद straight line function also be.
Straight line. Okay. Something close. Okay. You're getting there. Ji Saad.
Sir, I think it means that for a particular change in the input, there is like a equivalent particular change in the output, like equal for every step.
Okay. Right. So Saad, full marks for CP. Right. Ab to concern nahi hai. Right. So here's the definition I'm going to give you. So it's slightly different than what you said. It's quite different than what you said. So let's say there's an input x1 and that results in an output y1. Okay? And let me say there's another input x2 that results in an output y2. Okay? So Hamza, you're getting full marks for CP as well. Okay? And Zan and a few other people, Hassan. Right? And let's wait for others. Right? So a system is linear if, as actually only if as well, if for some complex constants A and B, the following condition is satisfied. Okay, if my input instead of x1 and x2 is now a linear combination of x1 and x2, right? So in other words, if my input is A times x1 of t plus B times x2 of t, if this is my input, a system is linear if this input results in an output which is A times y1 of t plus B times y2 of t. And it's called the superposition Okay, the superposition of inputs results in a superposition of outputs as well. Okay, is that clear? Okay, if I form a linear combination of the inputs, the output should be a linear combination of the component outputs as well. Okay, is that clear? Or essentially, I mean, it's a consequence of this is, okay, if I multiply A or the input with any constant, then the output is also multiplied by the same constant. Right? That's a consequence of linearity, right? And if a system satisfies the property, any complex input, any complex constant being multiplied with the input results in an output which is just simply multiplied by the same constant, the system is linear. Okay, or that's a condition that must be satisfied for the system to be linear. Okay, at the same time, agar main input x1 of t plus x2 of t kar deta hu, right, just a simple combination, a simple superposition, then the output would just simply be a sum as well. Okay, is that clear? This should be simple enough, right? Any questions here before I move to examples? And if this is sat, please, go ahead.
Sir, what causes a system to be linear? Like, yeah, what causes a system to be non-linear, to be precise?
Sorry, say again. What
causes a system to be non-linear? Like, ऐसा क्या होता है कि system linearity assume नहीं करता?
I'll give you examples. So examples of systems which are non-linear. So as somebody said, कि square terms नहीं होनी चाहिए.
Makes sense. Yeah.
Right. So if the output is input squared, that's a non-linear system, because this condition is not satisfied that you see on the screen. Okay. So and by the way, so you can use now induction to show कि this अगर मैं दो inputs के बजाय तीन inputs add कर दूं, तो output भी तीनों की तीनों corresponding add होनी चाहिए. And this is applicable to many inputs. So in other words, so we can conclude that any combination, so A sub k x k of t results in an output which is just simply summations. Okay, so it does not have to be restricted to just two inputs. Could be more than two, 3, 4, all the way up to how many ever you want. Okay, so this is linearity. Let me give you some examples, right? So the first example is, and I think this is from the textbook. And this is y of t equals t times x of t. So we found out that this system is, like we said, this is a memoryless system, and therefore this is causal. We found out that the system is unstable, as somebody argued, and we found out that the system is a time variant system. That's just an example before this. Now we want to see whether the system is linear or not. Okay, in order to check whether this is linear or not, all I'll do is I'll say कि जी x1 of t के corresponding output is t times, so is y1 of t, which is equal to t times x1 of t, and x2 of t results in an output which is y2 of t equals t times x2 of t, right? Just the input multiplied by time t, right? Now what if I take a times x1 of t plus b times x2 of t as the input? If that's the input, right, let's say, and this is some x3 of t, I know from the system definition that the output is going to be t times, so this is y3 of t is just simply going to be t times what the input is. And let me just plug in what the input is. So this is t times a times x1 of t plus b times x2 of t, and therefore this is a times t times x1 of t plus b times t times x2 of t. So is this system linear? This is what? This is nothing but y1 of t. And this is nothing but y2 of t. So therefore, what we concluded that the output indeed turns out to be equal to a times y1 of t plus b times y2 of t, and the system is linear. All right. On the other hand, so if y of t equals x squared of t, I'll let you do this on your own. You can verify that the condition, the superposition principle that I've stated up above does not hold true. Okay. And therefore this system is an unstable system. All right. Let me discuss one final example. And this is y of t equals 2 times x of t plus 3. So do you think the system is going to be stable or an unstable system? Ji, Abdullah Ali? Ji, Abdullah, do you think this system is stable or unstable?
Sir, पहला के दूसरा?
The second one. Example 3.
Stable होगा.
So stable, stable try. ठीक है. And is this system memoryless or with memory?
Memoryless.
Memoryless. Is this system causal? And the answer is yes, because it only depends on the present. Is this system time variant or invariant? Chalo, I'll let you verify that. But the question here is this system linear or not? That's what we're most interested in. So Ahmed says it's no. Why do you say that, Ahmed?
Because the x square is non-linear x square.
Yeah, I'm not talking about x squared. I'm talking about 2 times x of t plus 3.
Depends upon x of t, sir. If it is bounded, then it's linear.
So it should not depend on x of t. I mean, so a system property is independent of what the input is. I mean, systems are innate qualities of systems, regardless of what the inputs are.
It's linear.
So we can try to verify. Let's try to verify, right? So I'd say that if x1 of t, G, who was this? G San.
Sir, a random guess, but शायद वो जो 3 साथ में आ रहा है, तो एक जगह पर वो 3 plus 3 होकर 6 हो जाएगा शायद, और उसकी वजह से एक जगह पर जाके वो like उसकी वजह से शायद कोई फर्क आए, तो इसलिए वो linear ना हो.
Excellent, Zan. That's not shayad. That's actually exactly true, right? And we can then see as we can do this analysis and verify what you just said, right? So this is just y1 of t is this, okay? And x2 of t, that is equal to y2 of t, which is 2 times x2 of t plus 3. And let me take x3 of t as an input, which is just simply the sum of x1 and x2. What output do I get? The output that I get, y3 of t, is just 2 times what the input is, plus 3. And the input is just a sum of x1 and x2. Plus 3, and therefore this is 2 times x1 of t plus 2 times x2 of t plus 3 and not 6. And because of this exactly, then, as you rightly pointed out, this is not equal to y1 of t plus y2 of t. And this is enough for us to conclude that the system is not linear. ठीक है? Right. Any questions about this linearity? Okay, so let me just talk about one final example. So x of t equals real, all right, sorry, y of t equals the real part of x of t. Is this system a linear system or a non-linear system? If I just extract the real part of the system out, that's what the system does. Or sorry, it extracts the real part of the input and assigns it to the output. That's what the system does. Is this a linear system or a non-linear system? Right. Hamza says it's a linear system. Why do you say that, Hamza?
सर अगर हमारे पास किसी भी तरह का कोई कॉम्प्लेक्स नंबर है तो अगर आप उसका रियल पार्ट एक्सट्रैक्ट कर लो सर, फॉर एग्जांपल 2 + 3 आयोटा है आपके पास, तो जब भी आप इसका 2 एक्सट्रैक्ट करोगे, कोई भी रियल पार्ट एक्सट्रैक्ट करोगे, इट विल ऑलवेज बी अ सिंगल डिजिट नंबर, सो इट विल बी लीनियर.
Okay, so what if I say कि जी 2j times x का real part extract कर लें?
2j times
x of t. So remember the a constant that we talked about does not have to be real. That a can be a complex number, right? So let's say, so let x of t have a certain real part, which is xr of t plus j times the imaginary part. Okay, so let's say the input was a complex input. Okay, so Hassan, you said never mind. What does that mean? So you're changing your answer?
Yes, sir. I very quickly realized that it wouldn't be.
Yeah. Okay. Excellent. Right. So this is some real part and some imaginary part. Okay. And for this to be linear, I would expect, okay, for the system to be linear, a times x of t should result in a times y of t for any complex number a. Right? So that a constant has to be a complex constant, right? And you can see where I'm headed at, right? Where I'm headed now, right? So I can therefore give you an a, which is a complex number, which results in the output which does not satisfy this property. And here's a counter example, okay? So let a equals 2j, right? So x of t results in an output which is xr of t, right? And let's say the input was 2j times x of t. What is the output here going to be? That's the real part of 2j times x of t. And this is the real part of 2j times xr of t minus 2 times xi of t. So I've skipped a step here. Is this clear to everyone? Chale, let me not skip a step here. So therefore, this is plus 2j times j xi of t, right? And what is the real part for this? The real part for this is minus 2 times xi of t. Okay, and clearly we can see okay, this is not equal to 2j times xr of t. And therefore, from here we conclude that the system is nonlinear. Okay, because the constants a could be complex. All right. So I'm going to stop here and take any questions that you may have.
सर वो सेकंड लास्ट लाइन के अंदर ये 2j x real part of t के आगे क्या पर आया x3 of t है वो like I missed that, I'm sorry.
Sorry, which one? ये
से ऊपर वाला.
xi of t.
Yes sir.
So this is the
Sir,
imaginary.
sir, can you explain this? Like यहाँ पर मैं net lag कर रहा था, so I didn't actually get कि यहाँ पर क्या हुआ है.
Okay, so this, what is 2j multiplied by j then?
2j minus 2, yeah.
Minus 2, right? So up,
Yes, sir.
what you're going to get here, what is this? This going to be equal to, this is 2j times xr of t minus 2 times xi of t. ठीक है, इसका real part लेना है. So what is the real part for this? Right, so that's minus 2 times xi of t.
Thank you.
Okay. Any other questions?